So let me go over one last visual cue, which you can use if you want, and if you don't want, it might just help you in some of the homework problems you have. So if I want to label the major points all the way around the unit circle, I already know that 1, 0 is here. Remember, it's a unit circle, so the radius is 1. 1 unit above the origin, 1 unit to the left of the origin, and 1 unit below the origin. But how do I find the points that correspond to a 30-degree ray from the x-axis, a 45-degree ray from the x-axis, and for a 60-degree ray from the x-axis? How do I find those points? Well, here's what I know from yesterday. Sine is y and cosine is x. So if what I want is a point, and a point is of the form x comma y, and sine is y and cosine is x, then to find the x-coordinate, I just need to know cosine of the angle. And to find the y-coordinate, I just need to know sine of the angle. So if I'm using my 30, 60, 90 triangle, sine of 30 and cosine of 30 will give me y and x. Let me say it in order. Cosine 30 will give me x. Well, looking at your 30, 60, 90 triangle, what is cosine 30? Square root of 3 over 2 is your answer. The y-coordinate is sine 30. What is sine 30? 1/2. Now, if I look at my 45, 45, 90 triangle, the x is cosine 45. What is that? Look at your 45, 45, 90. You should see that it's square root 2 over 2. What's sine 45? It's still square root 2 over 2. And last but not least, for 60, cosine 60, look at your 30, 60, 90 triangle. Are you getting 1/2? And then sine 60 is square root of 3 over 2. Now, a lot of teachers just make their students memorize the first quadrant, and then from there you can build the rest of the unit circle. So rather than me saying that the second green spoke here is 120 degrees, and then me thinking, okay, what is cosine 120, comma sine 120? Instead, let me start with blue. This blue point is directly across the circle from the blue point that would correspond to the 150-degree ray. Well, in this quadrant, the x's are negative and the y's are positive. Now, when I pop to the 210-degree ray, for this point right here, the x's are negative and the y's are negative. So I'm using the same numbers for x and y. The only thing that's changing is the signs, which corresponds to all students take calculus. And when I go to my 330-degree ray, then my x's go back to being positive, but my y's stay negative. And if you understand that, you can transport the 4 red points and the 4 green points really quickly. So negative x, positive y. Negative x, negative y. Positive x, negative y. Can you finish out the green points? So that's all you have to do. And then I wanted to show you this last slide, if I can get it to change. If you want to pull this up on the hard copy, the PDF version of this lesson, then this is just, I actually just got this straight off Google Images, and it records what we just did. But notice you've got, for all the major angles, you've got the degrees and the radians listed on the rays themselves, on the spokes of the wheel. And then you've got your points all the way around the unit circle. So this is a nice little visual cue. And some teachers just ask you to use this kind of visual cue. So let me explain how. What if I said, please evaluate using this visual cue cotangent of 240 degrees. Well, here is the 240 degree spoke. If you remember that cotangent is cosine over sine, or x over y, you'll say your x is negative 1/2 over your y, which is negative square root 3 over 2. Now, the 2's cancel. The negatives become positive. Negative over negative is positive. So I'm left with positive 1 over positive square root 3, which is square root 3 over 3. That is different from the way I've been teaching you. It's not what I'll do in class, but it is a valid way to do trig if that's your choice.